Okay, so this is another, F1 and F2 are different, okay? This one's going to be solvable because this is a 90-degree angle right there, okay? And then this angle here presumably is 60 degrees, right? Okay. So draw a picture with forces as arrows, so there they are, right? Okay. Calculate the weights. Well, let's do that. 200 times 9.81 is 1962. So 200, that's a good year. All babies born on that year are blessed. Okay, so that's actually one. The textbook, by the way, uses 9.80 as the acceleration of gravity. Okay, so let's see. So F2, notice that F2 is positive and all of it is in the x direction, right? This guy is going to be negative and it's in the y direction. And then this force here has two components. One is this way and one is this way, right? This component here is F1. Here, we'll do it up here. F1, which is the hypotenuse is F1, right? That force, right? F1, wait, that's 60 degrees there. So it's going to be F1 sine 60, right? Because this side right here, this up and down part, is opposite that 60-degree angle, right? And then this guy here, that one's going to be F1 cos 60 degrees. Yeah, and this is negative and in the x direction because it's to the left, yeah? And this guy's going to be positive and in the y direction. Okay? So again, we just bust this thing up. So all of F2 is in the x direction. This guy's in the x direction, right? This one's in the y direction. And this guy's in the y direction. Okay, so now when we set up our equations, they will be actually solvable one after the other. So let's set up x and y. In the x direction, I've got minus F1 cos 60, right? Because that guy, this thing will be pulling to the left. And then I have plus F2 is 0. That's the only thing going on in the x direction, right? In the y direction, I've got negative 1962 newtons. What happened there? That wasn't me. That was my laptop taking a time out. Okay, and then there's this component here, right? Plus F1 sine 60 degrees. All right, and then those have to add up to 0, right? Well, I can't solve this one because it's got two unknowns, one equation, two unknowns, right? But I can solve this guy, right? So let's solve this one. Okay, 1962. I think it's going to be 1962 divided by the sine of 60. All right. 2265. So F1 is equal to 2265.52 newtons. I just did math here. Okay. Okay. And then now I can plug it in here, right? So this is like the first time we have to actually plug it in. Okay, so let's see, x. Let's take this guy. And I can plug that number into here. So I get x now is the opposite of not F1, but this number, right? Cos, right, plus F2 is 0. Well, doesn't that mean F2 is just the opposite of whatever's in these brackets, right? It's this. So I'm going to go that times cos 60. And it's 1132.76. So now we've got both answers. But just for fun, let's just double check this, right? So 2265, let's just double check our formula here. So opposite of 1962 plus, and then F1 is the 2265, sine of 60, that should equal 0 when I hit the enter button. And it's like times 10 to the minus 7, so that worked. All right. And then let's check this one out. So let's go the opposite of 2265. 2265 cos 60 plus f2. This should be 0. And that one's 0. Look at that. So I just plugged what I thought my answers were back into these equations, and sure enough, I got them to be equal 0. So there you go. So this one was solvable because all of this force was in the x direction, and that made this. They made this thing solvable here. There wasn't another variable here because there was no f2 in that equation. Okay.